we are going to look at Venn diagrams of sets. A Venn diagram is just basically a picture showing relationships of sets. So in this first particular example, we have U consists of all artists. So U is like our universal set. And when we're drawing a picture, we typically represent that universal set with a rectangle. So that's all my artists. And then they're asking us to select the Venn diagram that represents the following two sets. We have musicians and we have drummers. So you have to think about, is there any relationship between the two, or are they two totally separate sets? So, for example, when I think about musicians, I think about people that play the piano. I think about people that play the guitar. I even think about people that play the drums. So if we think of musicians as one particular set, I'm just going to put an M for musicians, then I listed drummers as part of that set. So now, are all drummers musicians or just part of them? Well, as a drummer, you would hope that you would be considered a musician, so they should all be contained inside of that circle. So not only are they considered an artist, they are considered to be a musician, and then, of course, musicians are considered to be artists. And so when we look at our different choices, this would be the correct representation. So we'll talk a minute about why the others aren't correct. In this second picture, it's saying there is no relationship, no overlap. So they're saying drummers are totally separate from musicians, which we know that's not true. In this third picture, they're saying only some of the drummers are musicians, where they overlap right there. And you certainly wouldn't want to be a drummer over here and somebody say, well, we don't consider you a musician, okay? And then the last thing, this one is saying all musicians are a drummer. So they're saying like people that play the piano are also considered a drummer, and that's not necessarily true. In my second example, notice that our universal set is they're using capital U, is described as, so we have Z such that Z is an element of, and that is the symbol that represents your integers. So integers include your whole numbers, 0, 1, 2, 3, 4, 5, and so on, as well as your negatives of those, -1, -2, -3, -4, -5. So those are my integers. All right, so also notice set A, that's equal to the set of Z, such that Z is a counting number less than 4. So with this particular set, your counting numbers are 1, 2, 3, 4, and so on. But if we say specifically less than 4, then that would be all of your counting numbers. Let me come back up here to U. So we said U is things like -3, -2, -1, 0, 1, 2, and 3, and goes on in both directions like that. Okay, so then they tell me specifically B is the set that has 1, 2, 3, 4, 5, and 6. So I always try to draw the picture first, just either in my mind or on paper. So you'll notice that A is contained in B. So when I'm looking at a picture, A should be totally contained in B because it's part of B. And then if you look at set B, it is also part of the universal set. So remember, the rectangle represents your universal set. So we're looking for a picture where U is represented by the rectangle, and since A has the numbers 1, 2, and 3, it should be part of B. So once again, this first one would correctly describe that. Notice the second one is wrong because it only says part of A overlaps B, and that's not true. All of A is in there. This third picture says there is no overlap, so that is certainly not true because we said there were numbers of A that are part of B. And then the last one says all of B is part of A, and that's the reverse of what we actually saw. Okay, so then we get to talking about how you can determine the number of subsets from a particular set. And subsets just mean like pieces of the set versus the number of proper subsets. And the definition of a proper subset means it's any part of the set but not the whole set. So You can't contain all of the elements that are in the particular set. And so there are formulas here that help us to determine this. We'll list some subsets, but then I'll give you the formula. So in this first example, we have set P. They're telling me is equal to the set of all x's such that x is even, it's a negative integer, and it's greater than negative 19. So if I think about the roster notation of that, so it's negative, it's even, and it's greater than negative 19. So negative 18 would be greater, even, negative. And then we'd have negative 16, negative 14, all the way until we get to negative 2. Okay, so I'm just going to kind of put those dots in there. Now, to demonstrate you in terms of what is a subset is any parts of those elements grouped together. So negative 18 by itself would be an example of a subset. Negative 18 paired with negative 16 would be an example of a subset. Even negative 18 compared with negative 14. So you could see we could be here for a while listing particular subsets. And even you could say the empty set is a subset because it could be that you choose none of the elements. Or you could say this whole set is a subset. If we're just talking about subsets, that would be included. So the formula for number of subsets is you take 2 and you raise it to the power of n, where n is your number of elements in your set. So you have to know how many elements are in your set. So in this particular case, I guess I should have listed them all. So let me finish listing them. So we had negative 4, so then we should also have negative 12, negative 10, negative 8, negative 6, negative 4, and negative 2. All right, so we have, if I count those, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different elements in the set. So when they ask me number of subsets, I'm going to go 2 to the power of 9. And that is equal to 512. So we'd be here all day trying to list all 512 of those. Now, when they specifically say or ask for the number of proper subsets, that means that it can include any grouping like these, but it can include the set itself. So in this particular case, I'm looking at set M, where we've got the variable x. X is an even number, it's positive, and it's less than 17. So if I look at the roster for set M, so it's even, it's positive, and it's less than 17. So 2, 4, 6, 8, 10, 12, 14, and 16. And if I count those, 1, 2, 3, 4, 5, 6, 7, 8. Your formula for number of proper subsets is 2 to the n, which is number of subsets, minus the 1, because you can include the set that is identical to, or the subset that's identical to the original set. So we had 8 elements, so we're going to take 2 to the 8 minus 1, and so 2 to the 8th power is going to give me 256. And when I subtract 1, then that's going to leave me with 255 different proper subsets.